or questions? We have 2 more minutes for this presentation. No? Okay. The next presenter is Gabriel RAMSSISS from France.
Hello.
Hello.
I will share my screen. Hello, so I can start?
Yeah, you can start.
Very fine. Hello, my name is Gabriel RAMSSISS. I'm a student of the Scientific Lab of the Vilgénis High School, and I will present to you the POLLUBIKE project, modeling and biking to measure the air quality. The POLLUBIKE project was born from the wish of getting information about the air quality in order to aware citizens about it. Indeed, before we start, I should remind you some important numbers, like the cities represents only 2% of the Earth's surface, while they made more than 80% of greenhouse gas emission. It's also 50% of the global population who lives in cities, and in 2050, this percentage could increase to 70. But come back to our POLLUBIKE. Everything started in 2018, when the Innovation Lab Ericsson France contacted us in order to start a partnership in the aim of developing a project about the air quality. The POLLUBIKE is a device fixed on a bike, therefore it can move through the city and measure the concentration in particulate matter. Then it sends the data to a server, which will then show to the user the pollution like red dots on a map. We also have the agreement of our city, Massy, to collect and use this data. Today, we have 4 POLLUBIKE like this one, including one which works with an electrical bike and one which is always with the biking association of our city. To achieve the project, we have 5 great steps. The first one is to determine the most suitable components for an air quality sensor. Then we need to develop a program to use them. After that, we need to search for a case who can be purchased on a bike. Moreover, we need to share to the people the data we have. And finally, we have our test phases that are aimed to improve our POLLUBIKE. At the beginning, we wanted to use microbit card due to the fact that we usually use it for our projects, but we must use a shield with it, so it took a lot of space. So consequently, we have changed it for an Arduino Nano. Now the sensor. The first time we wanted to use NOx sensor. NOx means nitrogen oxide, gases with direct effect on health, but it needs time to warm up and the data are quite hard to use. So we have changed for a dust sensor that measures the particles between 0.1 micrometers and 30 micrometers. Then we have the LTE and GPS antennas that are required to send the data and get the GPS localization. And here we can see our final secrets. We can observe that we also have a battery, of course, to power the secrets, and a SIM module to send the data. Now we have all the components. We need to develop a program to use them. The Arduino program had changed a lot, but today it's what it looks like. We first define libraries, pins, and variables. Then we have the setup function that simply starts the secrets. After that, the most important part is the loop, where we get the GPS localization. We measure the pollution of particles over 1 micrometers and 2.5 micrometers. And we convert the data due to the fact that the sensor does not use a classic unit of concentration, and we must convert the data into particle per million, ppm. And finally, we send the data to the server at the end of the code. Now we can measure the pollution. We need to put our components on a bike. At the beginning, the case were just a box that contains the components, and it was not really aesthetic. So we have brought another design with the shape of a cloud that reminds the pollution topic. But as you can see, it's really big and it's quite impossible to put it on a bike. Therefore, after much research, we have developed the current case that keeps the shape of a cloud but can be easily purchased on a bike. Now we are able to get the information about the pollution in the streets. We need to inform people about that. We are currently using dots on a map. The color dots, the color of the dots are fixed between green and red, according to the concentration in particulate matter and the air pollution scale. It's also important to know that a POLLUBIKE sends the data corresponding to a dot every 30 seconds. But we still have a problem is that the background map is supported by Google Map, and we need to pay for it if we don't only use that on a personal purpose. Therefore, we have changed for an open source map, which is called OpenStreetMap. With our 4 POLLUBIKEs, we have succeeded to get a lot of data. Today is more than 50,000 lines of data that corresponding to more than 2,500 kilometers on bikes. And this test, we have done many tests. We have did many tests, such as the Kolmogorov-Smirnov test that allow us to show that the orientation of the POLLUBIKE does not matter. We are also able to compare our data, such as after, before, or during the lockdown, or according to the weather. But moreover, the tests allow us to do improvements, such as adding a condenser or pushing away the antennas. Now, our next objective is to increase the number of POLLUBIKEs in order to cover the whole city of Massy. But if we have a lot of POLLUBIKE, that could be a real with too many dots. Therefore, we need to refresh the map. But the question still is, what is the best delay to refresh the map? So thus, we have built a Python code that modeling the movement of 100 POLLUBIKE in the city of Massy. And this program has shown that the best delay to refresh the map is 15 minutes. But we also observed that the correct dots on the map weren't really practical. So we have thought about a way to give directly to the user the best itineraries in terms of pollution and distance. To do so, we have first represent the city by an Excel table, with each cell representing a street with the pollution score. Here we have put 1, 2, 3, but it could be 1, 5, 9, but we need to fix it. After that, we have thought about different itineraries, and we have shown the best, we have thought about the best, depending on the cost, which is the sum of the pollution score of each street traveled. But we need differently to have a code if we wanted to use that instead of dots. Consequently, we have built a Python code that uses the Dijkstra algorithm with a matrix. We recover the matrix from OpenStreetMap, and we add the pollution in our calculation with the previous works, and we can give to the user the best itineraries. All in all, we have succeeded to build a working device that can measure the air quality in the cities and aware people about the best itineraries to achieve their travel. Now we want to find someone in the Paris-Saclay cluster or maybe a startup company that could take care of the industrialization and distribution of the POLLUBIKE. And we hope to see one day in our cities a lot of POLLUBIKEs. I want to thank you for listening to me.
Thank you, Gabriel, for your presentation. Are there any questions for Gabriel?
Thank you, Gabriel, for your presentation. I have a question for you. Have you compared your quality of the gas and different emission detection to the other devices that measure the quality of the air?
I don't understand. Can you repeat, please?
Have you compared your device with other devices that measure the air quality?
The problem, I understand. The problem is that our device is moved through the cities, while the other device, like the Paris one, just keep at the state place and measure the pollution at the specific areas, and we can't compare to other device.
But actually, you can move your bicycle to that place, measures the air quality there, and compare the results.
Yeah, I understand, but we're just able to get data in the city of Massy, and the Paris is just at the Paris city, and we just don't have the idea of getting to Paris and comparing the data.
Yeah, thank you.
More questions for Gabriel?
I've got a couple of questions, Gabriel. Thank you for this work and the research. A couple of questions. Do you think your device need calibration with respect of the special medical devices, or it could be enough to have a relative data around the city?
The problem of one POLLUBIKE is that it measures only the particulate matter, while the other device can measure a lot of other characteristics like I don't know, NOx or other things. But the advantage of a POLLUBIKE is that it can move through the city and measure, as I said before, areas where the other can't measure. So I think the best way is to do the both way, and just mix the data. But it's still very really complicated to use all the data and put it on our algorithm. So I think the actual way is to just keep our data.
The second question is the pollution have very different structure. I mean, for example, carbon dioxide couldn't be obtained by your device. It all depends on sensors that you use. Do you think that this device could be pluggable for using different type of sensors?
Yeah, it's not a problem. That just we need to put it on the box, and it can be easily added on our algorithm. It just we just need to add a function. So I think it's not a problem. The really problem is the actual problem is that we need to find a sensor that can be easily traveled and do not need a warming time or something like that.
And the last question, do you transfer gathered information online, or you keep it and gather finally in the final position? And why you choose gathering and or distributing online?
What do you mean by lane?
Online. I mean,
right.
yes, transferring online or keeping and reading.
Yeah, we wanted to inform a large people, a huge amount of people. Therefore, I think the best way is to put the data online and can be easily accessible. The people can access it easily.
Okay, thank you.
More questions?
Hello, Gabriel. I have a question. Before I should tell that this is a very interesting project. I have a question about what is the frequency between of measurements between the points?
I said that the POLLUBIKE sends the data corresponding to a dot every 30 seconds.
Every 40 seconds. Okay. And do you have any problems with your power supply device, and how do you plan to resolve it? For example, for what time is of powering on of your device now, and how do you plan to maybe to reconstruct it or something else?
Right. The power time of a POLLUBIKE is around 2 hours. We also want to we can reduce the price of our POLLUBIKE. Today it's around 70 euros to build, and to do so we can change the components by a printed cardboard or something like that.
Maybe you can resolve it with using the electrobikes.
Yes, we
connecting
have
with the
already
system.
one with work with the electrical bikes, and therefore we do not have a battery on it.
Okay. Okay, thank you very much.
Gabriel, thank you very much for your presentation.
Thank you.